Okay, work verification. So the work verification, like I mentioned before, how do we verify the work? We know that we need to verify the work according to the requirement in the specification or in the contract document or in the drawings. But how do we verify? Okay. What you see on screen now is one of those tests on site. This is called field density test using sand replacement method. This is, I would say, at the moment is the most common verification test that is done on site for earthwork operation, at least in Malaysia. And this is accepted by the authorities related to the work, and also by the consultant who designed the operation. We will go into detail on how this test is done on site. The concept is similar to the Proctor compaction test in the lab, but the sequence or the detail is slightly different, but it is about density. It's about density. Okay, these are some of other tests. Just now I mentioned this sand cone test or sand replacement method. In some country they call it sand cone test, and in some place we call that sand replacement method. For example, in the Malaysian standard 1056, we call that sand replacement method. In some of 8 STM standard, they use sand cone test, but the objective is the same, to replace the excavation, the removal of soil within on site with sand, and then that's why it's called sand cone test or sand replacement method. And then with this replacement, you will be able to identify what is the density of the soil that has been compacted on site. So this density is the one that we are going to compare to the benchmark density that we have established in the lab using the Proctor compaction test. Okay, other tests will be a rubber balloon test, nuclear density test, water ring test, and drive cylinder test. I hope you will find more information about these other tests from the literature or from the internet, and how are they applied. Today we are only going to go through this sand replacement method, which is commonly specified and practiced in Malaysia. Okay, let us look at the sand replacement method. Okay, if you look at this illustration, as you can see, this this is the compacted field soil that has been compacted. The darkened area is actually a hole or test hole that we have. We remove some soil and it will create a hole. Okay, so in the sand replacement method, according to ASTM 1556 or BS 1377 or Malaysian Standard 1056, once after we have removed this soil, then we will fill up this hole with sand. This sand is not an ordinary sand. It is a standard sand. Why this is a standard sand? Because this so-called standard sand has got a standard property. Okay. The kind of sand that we use in this test or sand replacement method test is a sand that has passed 600 0.6 mm or 600 micrometer sieve, but they are retained in the 300 sieve. So it passed 600, retained in 300. So we have what they call it, a standard size of sand that is going to be used to be filled up into this hole. And then because they are standard sand, so they have a standard properties in terms of density. So that's what we are looking for. We are looking for the density. For lab tests is density and volume, right? Especially no, we're talking about because it has a standard density. Then we can after that use this relationship between density and volume to get the volume. In the lab, we can easily use a mold or a standard container which has got a certain volume that is known. So that's easy. We fill up a certain amount of sand in a certain container, for example, and then because of that container size, we know the volume. We can calculate the volume from the dimensional characteristic of that container. But you imagine if we go to site like this and we start excavating a hole, and then it will not be a smooth hole. Definitely, it is impossible to get a very smooth hole like a cylinder container, for example. So this standard sand will help us to find out what is the volume of the hole. So basically, that is the reason we use standard sand, because we can correlate with the volume to get what is the actual volume side. So what will happen is that if you look at this formula here, this is why we need to know the volume of this hole, because we need to identify what would be the gamma dry. Remember the gamma dry, the density or unit weight here, the gamma, so which equals to weight over volume, weight or mass over volume, right? So this is this weight, this is volume. We can easily get the weight of the sand. If you put the sand inside here, we can weigh this the amount. We can easily put it on a weighing machine and get what is the kilogram of the sand that we put in. But to get the volume inside here, this is stuff. If we are talking about soil hole on site like this, so how do we get this volume? So that's why we use this sand, the standard sand, to replace the hole. And we, from the relationship between the value of the density of the sand, we will be able to get what would be the volume. Remember, the volume equals to weight over the density over volume. So we are looking for this volume, right? This volume here. This is what we don't know. We know the density. How? Because of standard sand has got a standard density. Let's say 18 kilonewton per meter cube. And then we know the weight because we can weigh the sand on the weighing machine, the amount of sand that goes into the hole. Then we can find what would be the the volume of this hole. So this is what we need. The, to find what would be the volume of the hole. Now that we know the volume of the hole, we will use the same relationship to find what is the dry density of the soil that has been removed from this hole, right? Now that we know the volume. So how do we find what is the density of the soil? We use the same relationship here. We weigh the soil. When you remove the soil, you can weigh that on a machine, right? So we weigh the soil and we divide by the volume of the hole, that which is already established from the sand just now. And then we will get the gamma dry. So that's what we are looking for. And then this gamma dry, this figure here, will be benchmarked against the Proctor test result in the lab. So this will tell us if the compaction here, the soil that has been compacted here, has achieved the required standard. So basically that is the concept of sand replacement method.